Okay. So any if you have any understanding on this, I'm just explaining that how I'm using carry. Add carry. It's a very important instruction is using of add carry. This is what, you know, one thing. If you're using a 8-bit microprocessor and think about you using integer unnecessarily. Okay, how much time it will take? If you say long, let us write this. If you say long, A, B, and C. A is equal to 10, B is equal to 20, C is equal to A plus B. If you do that, gone. That if you write this on any of the your Atmega 8-bit or the Arduino board or your 8051 or your 8085, anywhere you do that, they all will do the same thing. What first of all they do the move. Comma 10, comma 0AH, because 10 is 0A. Then store accumulator at 1000, because I allocated for A the symbol table. For A I put 1000, I put 4 bytes. Then I once again say this is 4 bytes. I'll say you stored 0. Then I'll say move immediate A comma 0, store accumulator 1001, move immediate A comma 0, store accumulator comma 1002, move immediate A comma 0, store accumulator comma 1003. See that how many instructions I have taken. And in the memory, if you do this long, sorry, this is only a long. This is for long, sorry. Long means I have to do this another 4 times. 1003 to 1004. See here. First I will store 0A. Then I will store 00, 00, 00, 00. See that? You'll store all the 8. So this will be copied how many times? 8 times. I have to read all the instructions and I have to do the operation. I have to store it back. That's such a so that's why if you take any microcontroller, you take that Arduino or anything, you first define char A. Then do the delay for I is equal to 0, I less than 100, I plus plus. If somebody tells me, if somebody could tell me this, how do you calculate this? The maximum is 255, am I right? I less than 255. Yes, it can go only up to that. So 0 to 255, I can go that. I cannot go beyond that because it's character. Oh, let's take 100. Let us put 100. Then I put a delay. Am I right? If I do instead of character, if I do short, please try this only in the Arduino board or 8051, not other boards. Don't try on other boards. I'll tell you later why it is. Because all of them are same as 8085. Because I don't know, you don't have 8085. That's the reason I'm telling you this. Now you put short A. Sorry. Short A. So the same command. I want the same command. Short A. Take how much time? Then long A. Then long A. What is the time difference? You can find out. If you could be able to find me, then you are great. I want to know that what is the ratio? Char versus short versus long versus long. Understand? I want to know that if this takes 1 cycle, this guy takes 10 cycles, this can take 100 cycles, this take 1,000 cycles, whatever it is. Or this guy take 8 cycles, 8 times. This guy take 40 times. This guy take 100 times. You can come out with any number, but started working on the maybe batch 1 and 2 who are working already start on the Arduino board. Please let me know. Arduino 8051. No, don't ARM. Don't go to ARM. I'll tell you why you're not ARM. I want to try with 8-bit first. ARM is 32-bit. I want to try with 8-bit. Then we will discuss how to do it in the ARM also. These are the things will give you a big clarity of what is this. Now, somebody asked me about this. I started because somebody asked me about add C and sub B. If I say that the school, if they teach you 76, subtract by 48, it is very easy. I don't have one number. I subtract here. This becomes 16. This becomes 16. This becomes 6. 16 minus 8 is 8. 6 minus 4 is 2. That is easy. Suppose if I tell you 208 by 149. 208 by 149. Not possible. So I take one borrow here. It's not possible. So this is, I have to put in weight. And I have to borrow one here. When I borrow one here, this becomes 10. This becomes 10. And this becomes 1. This is the first borrow. Then only I have to do that. When he himself cannot borrow, I cannot do that. So I put 8 minus 1. 8 minus 9. Not possible. I borrow 1 from here. So this becomes 9. This becomes 18. This becomes 5. Becomes 0. Now we do the same thing now. Am I right? So this is what we try. How do we try here is when I do the number 74 minus, this is in A. Move immediate A. 74. And move immediate B, comma 49. That guy will do that. For you, single digit, for him it's 1 byte. He does not bother. Now he will say that 5 and 2. He didn't borrow anything. So now the borrow flag, that's nothing but a carry flag. Both are same. Carry and borrow flag are same. He set it to 0 because he didn't borrow anything. For you, digit, for him, 8-bit. 8-bit is a 1 digit for that microcontroller. 8-bit microcontroller. Suppose you have here 89. That guy will do 4 plus 9, 5. Okay. Then what happened? He will set 7 by 8. It's 2. Not possible. 17. So I borrow. That time I set the borrow flag as a 1. Then I set here 1, 74. No? So this is, I already borrowed 1. This become 14. I subtracted 5. This is 6. I borrowed 1. It becomes 16. 16 divided by 8. I get 85. And I also set the borrow flag. Am I right? Then if you do printf, then you will check the borrow flag. That time you will get minus 85. Not minus 85, sorry. That operation is different. Forget it. Don't get into the thing. So no, it does not. Oh, if we do borrow from the black, it if this guy is 0, if this guy is 0, I do the sub with the borrow 1. That's what your problem. Then I think that sign flag is set to 1. The sign will be set to 1. If it is 1, it will give you, otherwise sign will be set to 1. Let me see that. I think I myself has not done quite some time. Let me write a thing. Let me write a program, 2-bit program, 1743. 18 25. Am I right? Now I first do the operation. When I do this operation subtracted, first one I do subtraction because it's only first byte. I know that. When you do subtraction, it becomes 8. It becomes 2, 1. Now when I do second one, I do sub borrow. Okay. When you do sub borrow, then the what is that? That the borrow bit is 0 now. Am I right? Since the borrow bit is 1, I'm trying to borrow 1. So now that borrow bit will be set to 1. Tell me that I have borrowed 1. I have borrowed 1. So you have to use this on the next one when you are trying to subtract. If you don't have 1, then you have to get some negative number. For example, if I do another number here, if this is a big number, now if I complete the borrow here, then don't use. If I don't, let me I think make it very clear now. Move. Let's say I wanted to subtract 1, 9, 25, 1, 6, 14. Sorry, 34. I say move immediate. Let me even write the program in this one. I think we can write directly on the thing. Assembler. We have assembler. Why we have to doubt? We have assembler, so we'll write it there itself. I'll clear the memory. Then I clear the programs. All the flags are clear. Now I say that move immediate A 25 stored 1000. I don't want to store anywhere. I say that now. Sub say move immediate B 34 sub B HLT. Now the borrow flag is not set and sign is not set. Everything. Now let us see that. Is stored at 800. This is what the instruction at 800. This is, we cleared this. Let us see the 800. What is the thing? I cleared the memory, so I have to do that one second. So in 800, this is the data, whatever program. What's happening? It's only a 3 lines program. Something wrong. Sorry, something wrong. I don't know why that guy is making this as a 4 lines program instead of that he's making so many programs. It's a old program, am I right? It's anything fault here? You can try reloading, am I right? That's in how there was some bug. That's a problem with this. I can erase this. It's fine. Okay. So some people who have used this is giving a good idea. Thank you. Then it's yeah, this is what I expecting. So only this only I've written only 4 instructions. Am I right? Then why it can so it's actually this. See that moving immediately 25. This is a thing. Thanks somebody else for advice to reload it. Now I execute them. Okay, let us see that. Let us execute one by one. Okay, now if I execute everything, 19 is stored. That is 16 plus 35, and this is 34. 25 and 34 are stored. Now I'm going to subtract 0, no flag set. Now I do that. See, carry is set. And sign is also set because it's become negative number. Now this carry is called borrow. Now let us do the other one. Let us do one thing here. As your doubt, I understand your doubt. I wanted to clear your doubt. I stopped it. Instead of 25, I make 35. I make 35, then I start executing. See that carry is not set. I'll discuss about auxiliary carry later. Okay, now sign bit is also not set because it's not negative. Okay, now the carry is not set. Now you want to see that what is happening. Now I see here, I add a code, move immediate A comma 21, move immediate B comma 24, sub borrow B. Am I right? Now sub borrow B. Now you see here how this is happening. I reset the registers. I reset the flags. I compile it. Then I execute line by line. Till the time I execute, I don't execute now this. Now auxiliary carry is there, forget about. Now carry, nothing is set. I execute this now. See, carry is set. Now let us see what is A. FD. Because it took the number from there. It took the number from there. Then it is subtracted that. Took the number from 21. Now it become 121 minus 124. That's why FD. Because there's 3 minus 3. That's not exactly. Now the same thing, if we make this guy, now you got here FD, am I right? Now let us see here. The same code. I do only one small change here. A is to 31. Now when I do 31, when I execute this guy, when I do this one, now borrow is set. So now it will subtract one more number, it becomes FC. See here now, see the code, it becomes FC. Previous was FD, now it has become FC. If the borrow is 1, it takes that also and subtract that number. We'll discuss about other flag later, that's parity, sign, and now right now we are discussing only about add parity. So this is the way the programs are getting compiled. Say, basically, I wanted to tell you today, how do we write assembly program? That's the thing. There's nothing. Mark. FC again. Okay. Now let us make this one as 35. Okay. Now I am trying to subtract 21, 35 with 24, 34. That's what I wanted. Now I'm subtracting first this 35 minus 34. It becomes 0, 1. And borrow flag is set to 0. Borrow flag is set to 0 because I don't borrow anything. Let's take this also 25. Let's take both 25. Then you will know very clearly. Both 25. Now I take both 25, 35, 20, 34, 25, 24. Now when I execute this, after this first thing, 35 minus 34. Now A become 1. See that A become, accumulator becomes 0, 1. And your carry flag, that is borrow flag, is set to 0 now. It's not set. Now I execute the remaining 3. Now once again, 25 minus 24. And borrow flag is set to 0. So 20, that is so 25 minus 24 minus 0. I get, when I do this instruction, sub borrow, I get 25 minus 24 minus 0. So if you see it here, once again, A becomes 0, 1. And I don't borrow anything here. I don't borrow here. So borrow flag is set to 0. Now let's change only one this guy. This guy I change it to 33. I change this guy to 33. Now what happened? Let us see that. I change this guy to 33. Very simple. Change it to 33. When I change this one to 33, when I compile it and when I execute it, see here, this is a problem. The moment I do that sub borrow, borrow flag is set to 1. Now borrow is set to 1 because I borrowed 1. I borrowed 1. This borrow, forget it, because I've done only this operation. Now the result is 33 minus 34. That is 133 hexadecimal. In the hexadecimal binary, if you do that, means 133 minus 34. How much you will get? You will get about 255. So now that the register should be FF. What A should be FF. See that A should be FF. You understand? Because these are all operating on hexadecimals. That's the reason. If you want exactly the code, come down. You see here. 33 become 21. And this become 22. 2 into 16, 32 plus 1, 33. 2 into 16 plus 1. If you subtract 1 minus 2 is F, because this becomes 17. 17 minus 2 is 15, F. Then I borrowed already 1, this became 1. Now I borrow from outside 1 once again, so it becomes 17. 17 minus 2 is F. That's why you have to be very clear about this type of subtraction and everything. They all that. See, the assembly is, you know one thing, the assembly is tough because of this type of operation. You don't do that. Because this is, if you subtract 1, for you it's only 10. Here, if you subtract 1, it becomes 16. That's the confusion. Now you see here, this is subtracted. You put SBB, subtract borrow, next instruction. Now we'll execute the remaining 3. Now what happens? Since this borrow is also there, I use sub borrow. Now thing is that 25 minus 24 minus 1, I get 0. I get 0 now. See here now. The A becomes 0. And carry flag is not set because I didn't carry. I didn't borrow anything. By chance, if I have it 24, think of it. One moment. If they have a 24, yeah. If I have a 24, then if I execute the instructions, I borrow already 1. It becomes 33, 23. Since I do the thing here, I borrowed 1, they set the set borrow flag. So this is what borrow flag setting and borrowing. So please, this is available to you. This, what do you call? Correct. It will not take the previous calculation. You are perfectly right. If you do SPB, if you do sub SPB, the difference is if you do sub means A, if you say sub B means A minus B only. If you do sub B, A minus B minus borrow. That is actually a carry bit. That is what the previous calculation is taken care if you do sub borrow. I think I can I've got a now fairly the first 2-3 classes. You people have understood little bit of assembly. Am I right? Fairly not bad. Now let me do one thing. Let me write few programs and give it to you. Try it on Sim 8085. Okay. And if you have a doubt, ask me. I will tell you that why I've written the program. What is the purpose of the program? Then you try to understand the purpose yourself slowly, aram se. Okay. Without any doubt. Then I think next week, before we coming to next week, you'll be having a good clarity. I don't know how much time you people have time to spend, but please spend it. Those who are in the college, these things will be very useful because if you understand that 8085 clearly, I told you it's a path to ARM. It'll be easy when I'm discussing about ARM next after 8085. Things will become very easy. Understand? That's why I'm trying to take more time to explain the 8085 because if you don't even see one microprocessor, you understand thoroughly. It will be 8085. One microprocessor understand thoroughly, and the easiest. If you do repetitive instruction, move immediate A to everything, and move A comma B, everything, all these things, we remove it. This becomes so easy. So please. So I'll do one thing. I'll send few sums and few things. And I have a small meeting now. I have to close the call right now and I have to leave. And we will meet, even though this class I took more time to explain. I know the reason why I've done it. Because I've explained to you all the thing. How do I do from C to assembly? And how do I execute it on the SIM 8085? How do I do complicate instructions, the add C and sub borrow? This has to be understood very clearly. How I do 16 repeatedly, the question will come because most people have a doubt on sub borrow and this. They ask you repeatedly. Same way, I will explain the next class. How do I do 8-bit multiplication? How do I do 16-bit multiplication? These are the questions are repeatedly coming in everywhere, even gate 2, everywhere. So if you understand the 8085 thoroughly and digital, then you should score 100% in the digital at all. If at all anybody writes in gate. And even this will help you in the college to get a good CGPA. Okay, so I need to close the call. I'll close the recording now.